Hello everyone, welcome back to my YouTube channel. And today we'll be discussing a design of a ride booking app, or you can say a design of Uber, what actually it looks like. Okay, let's get started. So before starting, let's discuss what are the functional, non-functional requirements. I am assuming that most of you know how ride booking software works and or have used an Uber or Ola app. Okay, so what all we do, first of all, whenever we come to the app, we select the destination and your current location. So based on that, we search what rides are available for us and what is the fare, and then we choose one of the ride. And there is one rider. It shows that one rider is getting assigned. We have to wait until the riders get assigned, and as soon as riders get assigned, our rider will be a ride is created, and that rider will come us and pick up and drop us at our location. So yeah, that's the function requirement. So we will be designing these functionalities. And for non-functional requirements, what we can do here is we have to make sure that the booking part of the system is consistent. So as you've seen my previous video of CAP theorem, it is necessary to choose between consistency and availability because we can't have both. So we are choosing consistency while booking the app, but the rest of all our systems should be highly available. And we need the ride booking to be very low latency. Okay. So this design will go one by one, solving our functional requirements and parallel solving our non-functional requirements also. Let's get started. Uh, so first is user want to search a ride. What here we can do is we can create a ride service which will has its own DB. We can save the ride details there, and as soon as you want to book a ride or you want to create a ride, we can name it as create a ride. We just have to send our current location and the destination location. Based on that, we will get a ride ID created, and there will be list of rides which is available and their price. So where this service will get information. So these ride information will get from an estimation service, which will tell at this point how much amount which we should pay or which is expected to be paid for that particular ride. Okay. So now, as soon as you hit an estimation service, we will create a or we create a ride entity straightforward because we are expecting that this is ride is gonna book. It is not a search. Okay, so we will be booking this ride. Same way, estimation service will also know that okay, these many requests are coming. Based on that, it will keep on evolving its price, and the surges which all it want to add, it can add there. Okay, so yeah. Now, since a ride is now created, okay, and now when a ride is created, now you will get a list of rides which are available. Like I want to book a bike taxi, so I will choose bike taxi, and then I want to my system to connect with riders and request the rider to accept that ride. Okay, so that we can have a rider service where it can have rider DB where it will store all the information related to one rider. Okay, so there is one polling app because our service need to know where that rider is at that particular point. So let's suppose I am a particular at a point A. So I want all the riders nearby point A to get to. I want to request those riders only which are at X radius of point A. So for that, I my service need to know where that rider is. There, what is that rider's location? So what we'll do is that this client will send that rider's location at every 10 seconds. Okay, so for after every 10 seconds, my ride will be updated. My location of a rider will be updated. Okay, but uh, let's see, do some estimations like how many requests will be receiving here. So let's suppose there are 2 million riders, active riders at a particular time, and we are sending these requests at every 10 seconds. So which is around 200K requests per second. And at these many requests, if we do our DB update, it is very costly, and also it will not be sustainable. So what we can do here is, as you have, as if you have, if I have, if you have seen my previous videos, you know that whenever we get a bunch of requests, we try to send those requests in a queue so that we can process that asynchronously without hampering our system. Okay, but here's one more catch: which DB should we choose to do these many rides? So what we have done is, there will be a rider DBs to save all the rider information, but for their current location, we are choosing Redis. So there is one feature of Redis where we can do geofencing. So we'll make use of that. And also we have queue where we will push the request and the consumer will update rider's current location. Okay. So now we know current location. Now how can one request a ride? So what we can do is, as soon as we choose a book my bike taxi, client will choose book my bike taxi. What we'll do is, we'll send request to again a queue, and this queue will be the message in this queue will be consumed by a consumer, which is a matching consumer. So what it will do is, it will ask rider service to fetch all the riders available at this particular point of in X radius. We will get all rider details here, and one by one we can ask them a send request to that rider that, hey, do you want to pick this request or not? Okay, but here is a catch: since there are multiple instances of these consumer working. Okay, so since there are multiple instances, so it may be that a rider is getting two requests at a particular point of time. But this is what we don't want. We want a rider to get one request only. So what we'll do is, this matching consumer will lock in the Redis. So it will log that rider ID in Redis so that others cannot log, and maybe for 10 seconds, we will have 10 seconds TTL, and then the log will be released. Okay, so like this, if we get n number of requests, we can loop in the sorry, if we get n number of riders at that particular point, we will go in loop. We will try to request rides for all the riders, and as soon as one rider accepts that, we will then create the ride. Okay, so this is how it will work. Okay, now let's see how our complete architecture will look like. This is our complete architecture will look like. We have two clients here, customer and rider both. Okay, so we have matching service, and the ones first, the flow will be like, the client will enter for both the locations, current and destination. Based on that, one ride will be created. If that ride is not getting terminated, we can have one reconcile cron. Like if someone has just created ride, search something and then kill the app. So we will just have cron to see that if that ride is initiated state, we will mark it cancelled. Second, as soon as the estimation service will give us some response, these many rides are available, we'll show them to the customer. Customer will choose one ride. It will then send request to, hey, match my ride. So we'll send request to matching consumer. Matching consumer will fetch rider details from rider service. Based on that, it will try to contact riders. Okay, as soon as riders accept, so as soon as rider accept that request, what we'll do is, we will try to tell rider service like, hey, your this I want to book this rider because he has accepted. So this will be saved in DB that this rider is booked, and that the ride is created. We'll inform the customer also. Okay, like this, our ride is created. The rider will can go to pick that customer. So this is the complete flow. This is what this flow will look like. I hope you get the understanding how we are booking and all doing these things. Now the question comes how we are saving data in Redis of these many locations. So for that we can use quad tree. There's quad tree is one option, and there's one. There are many options like quad tree is there, or we can use geohashing also. So I'll create separate video where I explain what quad tree and geohashings are. Okay, so stay tuned for that. And do let me know how did you like the video or not, or you want to me to create another videos on same design concepts. Till then, take care.